Hello, we are from class 22E Group 5 will present about simple and multiple linear regression. The data is about how the independent variable x is used to model the dependent variable y. All independent variables used included s1, s2, s3, s4, s5, and s6. All these independent variables are used to predict the outcome, dependent variable which is total overall reported crime rate per 1 million residents y.
In 3.1, as a researcher, we doing the scatter plot using SPSS. In 3.2, we can see the researchers finds that variable x until x1 until x6, the highest correlation is x1 variable. In 3.3, general form simple linear regression is used for the formula y equals to b null plus b1x plus error rate. 3.4 is about testing the regression slope. Analysis variable x1 is used because it has strong positive relationship with y to support this observation. F-test were used where hash null is rejected and hash alternative is accepted. In 3.5, coefficient determination is where the highest value of r, which is variable x1, if the r value of x1 is 0.757, it means that 7.2% of the variation in the independent variable y is accounted by the variation in the dependent variable x1.
The 3.6 is about the overfitting. In this case, it happens because the criminal report variable's data size is too small than the total overall reported size crime rate per 1 million residents. So it does not contain enough data samples to accurately represent all the possible input data values. The 3.7 is about the multicanality. From the variable center table, all the x values, which is from the x1 until the x6, are used because it's all had a positive relationship with the y. So there is no remove variable had been recorded. In this case also, the statistic tolerance value increase, then the variance inflation factor VIF will be decreased. When the statistic tolerance value will be decreased, so then the variance inflation factor VIF will be decreased. Finally, the 3.8 is about the model comprehension. A model summary and ANOVA table will be used in this case. In the model table, the R value is about 0.783, where the R square is 0.783 times 0.783. That's all. Thank you.
For the best data model that we choose is MLR because MLR is more specific and particularly in calculation and analysis compared to the simple linear regression. For this data set 2, we require to use multiple linear regression analysis because this case was complex relationships. Base 3.10 point prediction based on the best model. Based on the diagram above, the dependent variable y has a positive value of 100.394. Meanwhile, the independent variable of x1 to x5 is correlation because they are in positive value, except for x6 due to it was negative value, which is negative 3.231. We generate and estimate regression equation below. For 3.11 hypothesis testing, this hypothesis testing if the independent variable x1 to x6 has an impact on the dependent variable y. For x1, the value is below than 0.05, x2 to x5 larger than 0.05. It means the deviation from the null hypothesis is not statistically significant and the null hypothesis is not rejected.
Hello, good evening everyone. I'm Amir. Today I'm going to talk about multiple linear regression, which is commonly used statistical model in data analysis. By fitting a linear equation to the observed data, multiple linear regression (MLR) is a statistical approach used to represent the linear connection between a dependent variable and one or more independent variables. There are several advantages to using MLR. MLR can handle large amount of data as long as the data meet the assumption of the model. MLR is a flexible method that can be extended to include non-linear relationship by using polynomial terms or integration terms. To summarize, MLR is useful statistical data that can handle multiple predictors and provide a confidentable relationship between the variables. Thank you.